This is a continuation from our last video where I talked about factorials, addition, and multiplication principles. Now, in this video, I'm going to talk about combinations and exclusion principle. For clarification, there is also a thing called permutation, and in this problem, we wanted to pick 5 soccer players out of 12 to go do some practices or whatever, and we want to find how many different groups of 5 could be chosen. Now, for clarification, if we pick 5 players, say A, B, C, D, E, it doesn't matter in which order that we pick them in, as long as we picked these 5. They're all the same in terms of combinations. Now I could go in reverse, or I can go like this, and these are all the same for combinations, because combination doesn't care about arrangements. But they are different for permutation. And the difference between combination and permutation essentially boils down to arrangement versus selection. And combination which is what we're going to look at in this video, and permutation, which we might talk about in this video, but probably not. Now, in math, combination uses the notation N choose R. Sometimes you'll also see it as NCR. Now, in your formula booklet, there should be a formula which shows you what N choose R is, and in the event that they don't, here it is, N choose R equals N factorial over R factorial multiply N minus R factorial. Now, like I said in my last video, factorial is just this number multiplied by one smaller than that number, multiplied by one smaller than that number, until you go to 3 times 2 to 1. Now, what N is the total number of objects, and R is the number of objects that we select. Now, going back to a question, we're picking 5 soccer players out of the total of 12. So our formula will look something like this: 12 factorial over, 5 factorial multiply 12 minus 5 factorial, which would give us 12 factorial over 5 factorial multiply 7 factorial. Now you could plug this into your calculator and call it a day, but I'm going to open up the factorial and show you how to do it algebraically. Now that I've opened them all, we can start cancelling. And 5 times 2 is actually 10, 4 times 3 is actually 12, and we're left with 11 times 9 times 8. Now this is just simple multiplication, and you should get, 792? And that's 792 ways of picking 5 players out of a group of 12. Now, let's make it a little bit harder. Let's put a condition in. If Bobby and Robert are the only goalkeepers, sorry about that, are the only goalkeepers and cannot play in any other positions, how many different teams could be chosen? Now, we can just write down what we know and what we don't know. We know that Bobby and Robert are the only people that can be in goal. So, we can have Bobby in goal, which is one way. And, remember, product principle, choose 4 players. Well, because you have to fill up the team of 5. And we don't know how many ways that is. Or we can have Roberts in goal. Which is one way. And choose 4 more players. Now, it might be tempting for this, you would just write in 12 choose 4 or even 11 choose 4 because you thought, yeah, since Bobby is in goal, that means we have 11 players left. But that's not true in either cases because, again, both Bobby and Roberts are only available for goalkeepers and cannot do any other positions. So when Bobby is in goal, Roberts is still unavailable because he can't play anything else. So you're actually down to a total of 10 choices. So n equals 10, r equals 4. In this first scenario, you need to do 10 choose 4. And in the second scenario, it's the same deal. You have 10 players to choose from, and you need to choose 4. So it's 10 choose 4. There we go. So the total number of ways is 10, remember, and times 1. So it's 1 times 10 choose 4 plus, same deal here, we have the 10 choose 4 and with the and for that one way. So we will do 1 times 10 to the 4, 10 choose 4, I'm sorry, which you should get to 210 plus 210 equals 420. Nice. Now, I'm going to go a little bit further this time and introduce you with something called the exclusion principle. Whoops, sorry about that. Oh my, sorry. The exclusion principle. Exclusion principle is just when you don't want certain things to be together. Let's say you have a 5-digit code and you have the numbers 1, 2, 3, 4, 5 to fill in these in random orders. Now the number of ways to fill this in is simple. It's just 5 factorial, which is equals to 120 ways. But let's make it a bit complicated, that we don't want there to end with 25. So any 5-digit code ending with 25, we don't want that. Now, to solve that, we can simply find the total number of ways, and we subtract the number of ways that you can end up with 25. Now, how do you do that? Well, because we can think of that there's only one way to have the 25 between 2 and 5. One way. and product principal, there are 3 more digits to arrange, so that will be 3 factorial. Therefore, to find the number of ways that the code does not end with 25 is 5 factorial minus 1 times 3 factorial. And I'll just label this total and number of ways that we want to exclude. And that should be 120 minus 6 equals 114 ways. And for this, I'll pull up another example. Let's say there are, I don't know, 8 puppies and 5 kittens. And let's say that we want to choose 4 animals and at least 2 kittens. Sorry about that. 2 kittens. Now, first, we want to find the total number of ways to have 4 animals. Which is the total of 13. And we pick 4. 13 choose 4. And then now we should look for what we want to exclude. We want to exclude when there are no kittens and remember product principle and 4 puppies. So how many ways are there to have no kittens? 5 choose 0. And the number of ways to pick only 4 puppies is 8 puppy out of 4 puppies. Or rather 4 puppies out of 8 puppies, I'm sorry. And we also want to exclude the scenario where we get 1 kitten and 3 puppies. And to have 1 kitten, you have 5 choose 1. 3 puppies, you have 8 choose 3. Now, like what we did earlier, we're going to have the total number of ways minus the number of ways that we want to exclude. Also remember to apply the product principle in both cases. Let me circle in red. And. What this would mean is that 5 choose 0 will then multiply 8 choose 4 because that's the first scenario plus the second scenario is 5 choose 1. Remember and, so we have to multiply 8 choose 3. Now I'll just annotate this real quick. Number of ways to exclude total number of combos. Now, you can cheat like I did, or you cannot, but I cheated. So I plugged it into a calculator. 13 choose 4, you get 714 minus 5 choose 0, that's always 1. Anything choose 0 is actually 1 because, yeah, math. Multiply 70, that'll be 8 choose 4 plus 5 choose 5 choose 1. There are 5 ways to choose 1 things out of 5. Multiply by 56, that will be 8 choose 3. And that should give you 365 ways. And that's it. That's all there is to it. Have a good day. See you next time.